Good day all. Today we are discussing about the topic mathematical or classical definition of probability. Let's start. Let S be the sample space. Let S be the sample space and there are n mutually exclusive and exclusive equally likely sample point. Then there are n mutually exclusive and exclusive equally likely sample point, and A be the event. Let A be the event. M of them are favorable to an event A. Okay. Then probability of A is m by n. Then the probability of A is m by n. That is P of A is equal to m by n. This is the mathematical or classical definition of probability. Okay. Then let S be the sample space and there are n mutually exclusive and exclusive equally likely sample point, and A be the event and m of them are favorable to an event A. Then probability of A is equal to m by n. That is probability of A is equal to number of favorable outcome divided by number of possible outcome. Okay, number of possible outcomes. Okay, for example, consider a random experiment, that is throwing a dice. Okay, throwing a dice. The sample space is equal to 1, 2, 3, 4, 5, 6. Then let A be the event that getting odd number. Let A be the event that getting odd number. Then probability of A is equal to number of favorable outcome. Number of favorable outcome of A divided by total number of possible outcomes. Here total number of possible outcome is 1, 2, 3, 4, 5, 6. That is 6. And let A be given the getting odd number. That is A is equal to getting odd number 1, 3, 5. 1, 3, 5. That is m is equal to 3. That is the number of favorable outcome of A is 3. Then the probability of A is m by n. And probability of A is m by n. That is 3 by 6. That is 1 by 2. Okay. So this is very important. Okay. Next, advantages. It is simple and easy to understand even by a layman. First advantage. Second, to determine the probability we require only m and n. We only need m and n. The third, probability is obtained as an exact value, not a limited statistical definition. Here in this definition we get exact value, but in statistical definition, next class we will discuss about the statistical definition of probability. Okay. And the disadvantage is equally likely assumption may not hold good in practical situation. Okay, equally likely assumption. What do you mean equally likely assumption? Equally likely assumption means that each outcome of an experiment occur with equal probability. That is equally likely assumption. Okay, equally likely assumption means each outcome of an experiment occur with the equal probability. For example, if you toss a coin, that is sample space is head and tail, okay. Then the head and tail, the occurrence of head and tail are equal, okay. That is equally likely assumption, okay. Equal likely assumption is each outcome of an experiment occur with the equal probability, okay. But disadvantage is equal assumption may not hold good in practical situation. Second, probability can't be obtained if n is infinite or number of element outcome is infinite, okay. We cannot obtain probability. Third, in certain situation calculation is complicated. These are the disadvantages, okay. Next question. Two dice are thrown simultaneously. Find the probability that sum of the numbers obtained is 10, okay. Two dice are thrown simultaneously, okay. The sample space is 1 1, 1 2 etc. 1 6 etc. 6 1, 6 2 etc. 6 6. That is total number of possible outcomes, that is n is equal to 36, okay. Then we have to find the probability that sum of the numbers obtained is 10, okay. That is the favorable outcome are 4 6 5 5 6 4, okay. 4 6 5 5 6 4, okay. Probability that sum of the numbers is obtained is 10, that is favorable outcome is 4 6 5 5 6 4, that is m is equal to 3, okay. Then probability of A is equal to m by n. Here m is equal to 3 divided by n. N means total number of possible outcomes, that 36 possible outcomes, so 3 by 36, that is 1 by 12, okay.